Okay. Hello, everybody. Let's, I guess, take a seat, close the doors. Maybe, there we go, quiet down a bit. Good. Cool. So, my name is Brent VATNE. I'm here to talk about mobile navigation. I work on React Native, and I work on Expo, which is a company built around React Native. You'll see a bunch of stuff related to both those things in this presentation, but I hope that it is still interesting to people who don't use React Native yet and maybe will use it one day or even potentially have no plan to use it. I know this is a React conference and not specifically React Native, so I'm trying to kind of make it interesting for everybody, I hope. Thanks to our sponsors. Okay, so title is mobile navigation, but what is navigation, right? Like, I think on the web, people often think of the word routing more often than navigation. You have like React Router as kind of the main example of that. So when I'm talking about navigation, what I'm really talking about is how you move between the screens in your app. And you can kind of think of navigation as being made up of two pieces. There's like some state, so like what are all the screens that exist in your current history. And then there are some views, which are like how you represent those to the user, how the user interacts to manipulate the state, that kind of thing. So on the web, you start off with something that looks a little bit like this, right? You have a bunch of Chrome around your app. You have some stuff on the bottom with back button, forward button, various other things. You have a URL bar. You have reload, stop loading, etc. You can kind of jump between different places pretty easily. You can swipe back, swipe forward, things like that. All this stuff that just kind of is there, and you don't have to really think about it. It just works, and every app uses it. So when you start off a React Native app, there isn't anything like that. You can see I'm trying to swipe. Nothing's happening. There's no address bar. There's no like back button. Unless you're using Android, there's a back button. But that's a hardware back button. And yeah, so you kind of start off with a lot less. And you create a new app, you see this thing, and that's not really what you want. You want something that looks more like this. I guess I'm using iOS for all these examples just so that we don't have to double up on every video that I've recorded and every screenshot and whatnot, and just to keep it consistent. Apologies if you prefer Android. So yeah, we want something like this. So let's kind of break down here. What are these navigation patterns that are being used? And we're going to talk about these throughout the rest of the talk, so I just want to highlight them first. So the most basic type of navigation UI, which if you use React Router, you're probably familiar with, is a switch. So a switch basically allows you to switch between two screens, go from one to the other. That's about it. And usually when you switch to another screen, the screen you're on before is unmounted, no longer in memory, it's just gone. It might be maintained in some kind of history, so if you press a back button, you can go back to it. But generally, it's just not there anymore. So the name of it's pretty indicative of that. Then there's a very common pattern, which we saw in the video of iOS UI, is the bottom tabs pattern. So it's very similar to switch, except it actually has some UI associated with it. So the switch, all it uses as its UI is whatever the components are that the screens or the routes correspond to. With tabs, you have this actual bar on the bottom, and then you can use that to interact with the navigation state. And so if you click on one of these, it brings you to another tab, and so on. Typically, with tabs, you actually keep all of the tabs that have been tapped on in memory, unless you have some kind of constraint about maybe one tab uses too many resources, and so when you switch away from it, you might unmount it or reset the state or something like that. But typically, you do this because you want to actually maintain the sort of local state to the tab. So there might be something like the scroll position on a scroll view. So if you're on your Facebook feed, you scroll halfway down, and then you switch over to another tab, and then you switch back to the feed. You expect it to be in the same scroll position you were at before and not back at the top of the feed. And the third and last one that we're going to look at is the stack, which essentially does this kind of thing. You know, you go to a new thing, slides another screen in on top, or on Android, right, fades it in on top. And the screens behind it, behind the one on the top of the stack, stay in memory as well, because same reason as with the tab pattern, you need to maintain the state. And this is actually one of the things that makes mobile navigation and mobile apps feel, I think, significantly better than web apps a lot of the time, is that when you go back on the web, you essentially are re-rendering the entire page again, right? It's not staying in memory. And the browser does an okay job of like recreating some of the state on that page. It might try and like put form fields back to the state they were in before, or scroll you back to where you were before, but it's not as reliable as if you just left the thing there and moved the other screen on top of it. And so this allows you to swipe back and immediately be able to interact with the screen that you were on before and have it in the exact same state that it was in before. That's what that looks like. All right, so yeah, back to this. We have this thing. We don't have any of those. Let's imagine that there aren't any libraries to do this for us right now. And we wanted to create one from scratch. First question, I think, is like, what are the tools that are available to us? If this were the web, basically, this is what we could do. We would make some kind of like maybe navigation component. You might have a header and like various scenes. Ultimately, it would all go down to divs and spans and whatnot, because that's what you have to work with, right? There's really not much else you can do other than render it down to the primitives that are exposed to you by the web platform. So it basically just ends up being React components all the way down. One thing that's a little bit different with React Native is you're able to create your own host components. So a composite component is kind of anything that you define in user space on the web with React. And every composite component either will eventually return nothing. You can return null from it, or like a fragment or something, I suppose. But they'll either return that or a host component. So the rendering process in React, right, you render at the root, and then you recursively render all children until you get to a tree of like native host components, which on the web are divs, span, et cetera. And on native, there's like view, text, text input, image, web view. Web view is kind of similar to an iframe. And on React Native, we're also able to create our own host components. So if there isn't something exposed to React Native already that does what you need it to do, but it's available on the operating system, or it's maybe too slow to implement it in JavaScript, and so you want to implement it in whatever the native language is for the platform you're using, you can do that and then expose it as a host component to React and React Native. So another tool we have to work with is that we're able to access any operating system API. So we don't just have to limit ourselves to things that can be wrapped in a component, something that like appears as a component in your UI. The prompts there, for example, those are just function calls that tell the operating system to open a prompt. None of the components inside of that are rendered by React. The calendar that I was looking at just there, it calls into some calendar API, gets the calendar information, calls into a permissions API, et cetera. Here we are doing a download. So we're able to expose any operating system API that's public to React Native as well. And this would be like as if on your web browser you were able to call into like any Windows API or any Mac API or any Linux API. And so that's something that's not quite available on the web. So we kind of have two options with React Native, right? We can take the approach that we would on the web and render down to the platform components and kind of just have React components all the way down. Or we can implement the navigation library mostly on top of the native navigation APIs. Because both platforms give you a lot of these patterns that I was showing you before out of the box. There are like frameworks that do that for you to provide that kind of consistency and developer experience when building a pure native app. So this is a really common dilemma between cross-platform mobile development tools. So Flutter, for example, they actually implement navigation completely from scratch using something more similar to building everything on top of the React primitives. There's a more complicated reason for why, but basically they're not actually able to interact with the view system for the most part using Flutter because it all renders down to OpenGL. In Cordova apps or PhoneGap, you might notice that, they typically also recreate the user interface using the same approach there, but ultimately, it's kind of hard to recreate all of that, I guess, in a web browser and get the same kind of user experience. So what some of them will do is actually use the second approach and implement sort of this wrapper around native navigation APIs, and then each screen will be like a web view that you transition to. So an example of that's actually quite nice is the Basecamp app, which you can take a look at to see sort of what's possible using that kind of approach. So in React Native, there are a lot of implementations for both of these options, but we're going to look at the most popular for each of them and kind of look at what the trade-offs are in the different approaches and what their different strengths are. The first one is to implement mostly on top of the platform navigation APIs. So this is demonstrated with React Native navigation. Disclaimer, I work on the other one I'm going to talk about later. I'm trying to be as fair as possible, and I think they're both good, but I just thought I would mention that in case it's relevant. So this is typically what a React Native app looks like when you do a hello world kind of thing. You just have an app at the root, you export that, and React Native will render that into some root view at the base of your app. And from there, you kind of have to render everything else inside of your app. So React Native navigation changes this a little bit. What they do instead is you don't export any component at the root, but instead you register a bunch of components that will be rendered at different roots. So you can think of this similar to like having sort of iframes in various places. So you have a bunch of native platform API, and then you drop these like little iframes in various places. Or another way to think of it is to call like React.render and target different containers on your page. So you have like a bunch of different React apps sort of inside of one thing where they don't really know about the UI around them, but within their self-contained space, they're there. So first thing we need to do is like register these various screens, and I'm added a button there as well so we can see how that works. So fairly straightforward. Then we listen for a launch listener, which is like listening for document ready or something like that in the browser. It just has some default options as well, nothing too fancy. And this is kind of the heart of it here. To initialize the app, you call setRoot, and then you provide this object that specifies the layout of your navigation. So at the root, we're going to have some bottom tabs. The bottom tabs will have a couple of children. Actually, we're going to do two children here. So the first child will be a stack, and the stack will have one child. We're just going to put the first screen in there. And the second one will be another stack that has another screen. We don't have to use a stack for this, but usually when you have tabs, right, you can like navigate within the tab and push some new screens on top and then switch tabs and then have an entirely different kind of navigation stack. So to see how we can push another screen on, just go into the first screen file. There's nothing fancy here, just some text and a button. And more importantly, what we're doing is importing the navigation object from React Native Navigation and then just calling push on it. And we're telling it what we want to push to our current stack. And we're just going to add the second screen on there. So what we get when we do that is this. So there's like a header bar at the top. There's a tab bar on the bottom. When we switch between screens, we get the kind of typical iOS UI for it, and we can swipe back and that sort of thing. So that's already a lot better than what we had when we just created it and had nothing. But there are a bunch of things that are sort of missing here, like you can't see any labels on the bottom, you don't see any icons. So let's add those. So if we go to first screen again, we can create an options static, and within there we need to return an object that has a bunch of options. So this is kind of how you configure React Native navigation. You have layout, and then you have a bunch of options that you can configure. And so for the top bar, I'm going to add a button. Again, I pointed to this button that I registered before as a component, and that will kind of do the equivalent of calling react.render and place it in the spot where the right buttons go in the navigation bar. And then I'll give it a title as well. For the bottom tab, I'll just add some text and give it an icon. Don't worry about the details. I can post a link to this example repo, and it's all in the documentation for the project as well. So now when I click on this button up there, we see that that's there, it's good. I have a title, the title transitions as we expect. I can switch between tabs and do this kind of stuff. So there are a lot of options that are exposed in React Native navigation. This is an incomplete list of them, but there are plenty more. So there's definitely a lot that you can do to customize your app. So one of the downsides of this approach is that React Native isn't really aware of what to do in this kind of situation where it has multiple routes. It doesn't handle that too well. So as you can see when I open the element inspector, like I have an inspector in the top right where the button is, because that's, as far as React Native is concerned, like a separate, completely separate app running there, although they share the same JavaScript bridge and runtime. So it ends up opening this different inspector in the top and in the main section as well. You'll also notice that it doesn't know anything about the header bar or the tab bar. I can't inspect any of the contents there. I can't do any sort of stuff like that. And so essentially what you see on the left is like the red areas are areas that are controlled by React, that are that the React runtime is able to inspect and know about, and then the rest of it is kind of just, it's outside of the control and sphere of knowledge of React. And, yeah. So part of using this approach that's really nice is that we can use some pretty advanced functionality with just simple options. So we can like set this new large title style by just adding one property to it to expose that to React Native navigation users. It's quite simple. There's, I don't know how many lines of code, but I can't imagine it's more than a few, because it basically just sets an option on the navigation controller. And that works out pretty nicely, except in situations where you want to have some consistent UI between maybe iOS 11 and iOS 10, or which is the example here, or some other different versions of whatever operating system you're using. And you'll see that like this navigation UI, like the large title and the search bar, those don't exist on iOS 10, so you just get a title. And so ultimately, you probably need to implement your own search bar here as well. So that's kind of one downside to this as well. I mean, some people might interpret it as an upside in that potentially you are not using patterns that exist on new versions of an operating system on old versions of it, but it really depends on your perspective on that. We can also use some really neat APIs like peek and pop on iOS. So if you like force touch and you get a preview and then jump right to the screen, and that's quite easy to implement as well. You just wrap some button with a navigation element, give it an ID, and then call this function when we press in. And that function basically does the same thing as we saw with the push before, except it adds an option with this preview key, which refers to element ID. And then you can configure what buttons you see when you swipe up while doing that and that sort of thing. So it's pretty powerful to be able to do that for sure. So what I've showed you so far are things that like exist that are part of the native navigation APIs already. But you can also build other things that aren't part of the native navigation APIs and build them into React Native navigation so that Shared element transitions, these aren't part of UI navigation controller or anything like that. These are just things that you have to build on your own. And the philosophy that the maintainers of this project take is that if it's a common pattern that you do in navigation and mobile apps, then they want you to be able to do it with React Native navigation. There's definitely a lot of work that needs to be done to fill out all of these cases. Support for like shared element transitions on Android is incomplete apparently, and this is experimental still. But I mean, it works really great as far as I can tell. Performance is really good, and I won't show the code because there's a lot of it, but I'm sure it's probably not too hard to actually implement. The Facebook app uses an API that's similar to React Native navigation because this is actually, I mean, there are some small exceptions, but generally speaking, this is probably the approach that you're going to take if you have an existing mobile app and you want to incrementally adopt React Native. The reason for that is that you already have your app which uses these native platform navigation APIs, and maybe one screen at a time, you want to be able to replace a native screen with a React Native screen. And so navigation is the thing that kind of ties everything together. And if you don't do that if you don't integrate your React Native views into that, then it's not really possible, I guess, in many situations to make that work. And you probably couldn't even tell like which of the screens here are implemented in React Native, but there are some that are. For example, the Marketplace tab, which I'm on right now. This is all implemented in React Native, but you switch to it and you don't even notice. And these all just call out into the native navigation APIs to do various kinds of navigation. Artsy is another company that does this kind of approach. So I think they're the company that speaks most vocally about it. So if this is kind of a path that you're interested in, if you already have an iOS app or Android app and you want to pursue integrating sort of incrementally React Native into your app, probably check out some of their content on this. They did a small conference where they discussed it, and it was quite good. Instagram is another app that does this, but I'm showing it more to make a point, which is that from the last couple of apps that we've seen, and Instagram included, you'll notice that a lot of navigation UI is like pretty heavily customized. There are even very subtle things like when you swipe forward and back, the navigation bar crossfades in place, and the items in the navigation bar, and there's no sort of translating the components left and right. There's things like swiping to go over to this sidebar, swiping to go over to the camera, to your direct messages, that sort of thing. There's really a lot of customization that happens in iOS and Android apps in terms of navigation. And I encourage you to just check out the 10 apps you use most frequently on your phone, and then compare them to like the settings app on iOS and be like, okay, how similar is this? And you'll probably find that there are a lot of different ways where they change. So let's look at how you might customize React Native navigation to make this kind of header transition. So React Native navigation actually gives you another option for customizing animations. So you can customize the push animation so that the alpha is the only thing that's animated. It animates from 0 to 1, let's say, with a 250 millisecond duration. Similarly, you can customize pop. And so when I do this now, right, they fade on top of each other. Unfortunately, I don't know if this is a bug or not, but when you use, like, you can still use the swipe gesture and it doesn't use the animation in that case. And when you press the back button in the header, that doesn't work. But probably it's a bug, and they'll probably fix it. But so that should be like pretty straightforward to do that simple example. A more advanced example would be like this swipe gesture between going to direct messages, which should start anytime now. Let's press play. There we go. So swiping over to direct messages or swiping to camera. There's not really like, unless someone builds this kind of functionality specifically into React Native navigation and gives you an option for it, there's not really like a way for you to do that. And so it's kind of limiting in that case. You can't possibly express this through the options that are exposed. So that's a little bit of a downside. Another thing is that the tab bar here, so we could probably do the tab bar because it's pretty similar to like the standard iOS tab bar. But a lot of people, for better or for worse, want to do weird tab bars like this. And if you get handed this requirement from a designer, and you're not in an organization that values the input of developers that much, then you might be kind of obliged to implement this kind of thing. And I don't know how you would implement this with React Native navigation, aside from going and writing some iOS code and some Android code natively, and then exposing that to JavaScript. And to me personally, that is not what I'm using React Native for. Anytime I want to implement some UI that is slightly more complicated than what is provided by the platform, I don't want to have to go and write native code for it. I want to just be able to build it from powerful primitives in React. That said, I don't think this is really a damning sort of situation. A lot of organizations do have iOS and Android developers and mix them with React developers on their React Native teams, and so you can have them do certain parts of it and help you out with it. As well, I mean, there's a lot to be said about just getting these really robust and featureful and performant navigation APIs that exist on the platform that you can really quickly take advantage of and build like a good app that feels nice and looks nice on the platform. So if your app has like a pretty similar UI to what you'd expect from the base sort of platform APIs, then probably React Native Navigation is a good choice, or another library that uses that approach. And again, if you are building an app that already has a bunch of native code and you just want to incrementally adopt React Native, then you probably need to use something like this. I don't think React Native Navigation has like a well-developed path for how to do that, but companies like Artsy have done it, and Facebook and Instagram, and Airbnb, which I guess doesn't use React Native anymore, but that's another story. Another option, the second option, is to implement the navigation APIs mostly in React and JavaScript on top of generic platform primitives. And so we'll look at React Navigation for this. Again, going back to this Hello World app, what we need to do to make this work with React Navigation is we render some navigation component at the root. So not a significant change. First thing we're going to do is create a couple of stacks. Don't worry too much about the details here. Then we create this navigation component, which is bottom tabs with these two stacks inside of it. The things before the colons are the route names. After that are the components that correspond to the routes, so the screen components. So that code that we were just looking at would go where the comment is, and then we just return navigation. When we want to go to another screen, we can call push on the navigation prop and pass in the route name, and that will push the new route in. So this is what we get when we run that code. Switch between the tabs, and go back, etc. You can swipe back. It's pretty similar. We can add some more configuration here so that we have the tab bar properly configured, that we have a title and icon and whatnot. And so that's just, again, configuring some options. Feel free to read the documentation for more information. Won't go into too much depth on that. Configure it again for the screen to add the title and a button. And then when we go back to the app, we have very similar kind of thing to what we were looking at before. And this is implemented all with React components. So you can see as you click around, you can inspect anything. You can see all the styles for them. Nothing is out of the scope of React in this context. So there's certainly some nice attributes of that. Again, on the left, that's the example with an approach like React Native Navigation. So what if we were going to add like this title, large iOS title and search bar to React Navigation? Nobody's actually implemented that yet, so you can't really do that unless you implement it on your own. So far, what exists is just the standard normal size header, and there is no implementation of that iOS 11 style search bar that has a really nice transition and that kind of thing. So instead, what you need to do is use a React component. So this is just search in the way that a lot of apps actually implement search feature. It just is like another screen in the app. You go there, pops the keyboard open, you can type in there. And this is just the package you can install from npm, and don't have to link any native dependencies. Install it, add it to a screen, drop in the search layout, configure it a little bit, and you're good to go. And so now we can add this to our navigation tree. So we're just going to create another stack at the root. This time we'll have no header because we're just going to render the header on our own using the navigation search layout. And then we'll just set it up to have no transition. So it's just going to pop in the other one. We could set it up to fade also. You can check the source afterwards to see how to make it fade. I did that in the repo, but it's a little too much code for this slide. What about peek and pop? Yeah, you can't do that either right now. It might be possible in the future, but that's just not an option at the moment. So that's not great. Shared element transitions, you can definitely do this. They're not quite as performant in some situations. You have to be a little bit more careful about that. But it works on iOS and Android already, and you can kind of implement this however you like as well. This is just one person's implementation of shared element transitions in a library called React Navigation Fluid Transitions, I believe it's called. So one really neat thing about this approach is that you can actually run React Navigation on other platforms because it doesn't depend on some native iOS or Android API for navigation, but instead it's built all on top of primitives that exist, like view and text that map to div and span, and image, which is just an image tag and whatnot. And so you're able to, in this case, this is using React Native DOM, which is a pretty neat library that kind of recreates React Native in the web browser inside of web workers and uses WebAssembly for the layout engine and that kind of thing. It's kind of wild. But it works with React Native Web as well. It just might take a little bit of fiddling to get it to work. In theory, though, it should work pretty well most of the time. And so the reason for this is that we can just swap out these low-level primitives. So you might have heard of React Native Web or React primitives. Basically what those do is provide a mapping from view and text and the various props that you would pass into that to the underlying platform equivalents to those components. Unfortunately, using this approach, you don't hook into the native view lifecycle events. So you don't normally on iOS and Android take a screen and just wrap it in like a UI view or an Android view. You use some kind of navigation controller or like fragments or view controller or something like that. And so if we were to just naively use views to wrap every screen, we would never invoke any of these lifecycle events. And the result would be that the views would not be capable of kind of responding to the fact that they've become inactive and releasing some resources they might be using. Maybe that's like a decoded image that's sitting in memory, or maybe it could be like something that uses battery, like maybe you have the camera mounted on a screen and then you switch to another screen and the camera is still running, but it's just behind the currently active screen. And if you're using the native navigation APIs, that would just happen automatically because these library authors would just make that work. A good way to get like a gut feel for what this looks like is to look in the UI hierarchy in Xcode, and then we can see that all of the screens that we have gone to before in the stack are still in the render list. They're still in the view hierarchy, and that's not great. So thankfully, like I mentioned before, we can expose really whatever APIs we want as long as they exist. And so if we swap out a view with a screen, Then on the web, maybe we just use a div because there's no concept of some native lifecycle events. We could maybe use some other component that sets like display none to inactive screens or whatever tricks might exist. But then on React Native, we could use something like some custom screen component, and that should then trigger these lifecycle events when the screen becomes inactive. So we built this thing called React Native Screens, and it's currently pretty early, so you have to opt into it by using this, but it's working quite well so far, at least. I've heard Android P, there's some issues, but iOS and Android, aside from P, it's working pretty well. And so if we do the same thing again and open a bunch of screens here, let's open a lot of them, and then inspect the view hierarchy, then we'll see we just have this one thing now. And then there's some other stuff there, but that's all unrelated to navigation. The one part that hasn't been solved here is that the header kind of duplicates itself on different screens, but that's something we can also address in the future. Because React Navigation and these similar sort of libraries are built on React primitives and these sort of components that are implemented, like most of the logic is implemented in JavaScript, and there's kind of just these core, more stable native components that back them. This approach works really well with over-the-air updates, which is basically a way to update your app without needing to submit it to the App Store or Play Store. You can just build a new JavaScript bundle, upload it somewhere, and then the users can download that and run it, and you basically circumvent that process. So things like Expo, which is something that I work on, that supports that out of the box. Or if you use like Microsoft App Center, they used to have a thing called Code Push, which I think is folded into that. That works pretty well too. So we've seen so far that you can customize these navigators by using options, whether it's like on the screen itself or like in the actual, when you initialize the navigator, right? And that looked like kind of like this. We'd create some kind of navigator, pass in the route, pass in the screen name. We could pass in some options there as well. And then we'd kind of have that as like one sort of way to do it, which is very similar to how we do it in React Native Navigation. One thing that's really different, though, is when we hit a wall and there's something that we can't do with options, we can actually create our own navigator just in React using React components and integrate that into the rest of our navigation flow, and it'll just work seamlessly. Whereas if you were doing that with a library like React Native Navigation, you would need to write native code for iOS and Android in order to make that work. So let's just have a quick look at how you can build your own navigator. So navigator, as we've seen, is a thing that has one or more routes. Each of those routes corresponds to a screen. The screens can also be navigators. So screens are just components, navigators are components. Navigators have a specific contract in that they expose a certain property, and so that's how we're able to detect that something's a navigator and not just a typical screen. Navigators tie together like the state and the state updating logic with a navigation view. So to create a navigator, we import create navigation container, and then just some kind of router. And a router, you can, like I said in the previous slide, is like a reducer, basically. You take the current state of navigation, and you take some action, like push or navigate, and then you return the new state of navigation. So we do that, and we pass in a navigation view in a moment. So okay, we have this function, create my first navigator. We instantiate the router from the route config map, which was the thing that's like route name to screen component and some config. Then we create the navigator using that view and the router and the config. And then we wrap it in a container. The container is just like putting a provider around it if there isn't any context that exists already. It's kind of using the similar pattern to Redux. Inside of the navigation view, we can take the state off of this prop that's provided. And the state will look something like this. So we have like an index, which represents the selected route, some unique key, and then the routes for that navigator. And in this case, we have one called home and one called profile. So we can grab the active route key from just grabbing the active index off of the route. And then we can get this thing called a descriptor, which will give us access to the options that are defined for the route, the component, things like that. All these sorts of things. Next thing we do is basically just render the screen component that's associated with it. And at this point, what we have basically is a switch navigator, right? We render only the thing. If you switch it to another route, then that route is just, the screen for that previous route is unmounted, and this new one is mounted in its place. If we want to add a tab bar, now we can call like render tab bar, pass in the active key, and then we just render a tab bar on the bottom of the screen, give it some color depending on whether it's active or not, and that's about it. Now we end up with something like this, so we can just switch between tabs. And this will integrate with the rest of the like nesting that we saw earlier of how we had like tabs with stacks in them. We could add stacks inside of this, and that would work fine also. So I think it's important to kind of realize that like when something doesn't work for you with React navigation and these kind of JavaScript, React-based libraries, you can just build the thing that you need in React and use it on both platforms. So it's a nice advantage. We could even like go ahead and swap out the tab bar for like a drawer layout. And this uses a library called React Native Gesture Handler, which leverages the native gesture recognition APIs. And so you don't have to make any sacrifices in terms of the quality of the gestures or the animations because you're using this approach. The key is to just build it on top of these really solid generic primitives. And then when such primitives don't exist, you circle back and try to build them. And so that's what we did with React Native Gesture Handler, with React Native Screens. There's another library called Reanimated that integrates with React Native Gesture Handler. And yeah, what we get when we run this is basically something like this. And we could go ahead and change the type to that. And ultimately, as a consumer of this library, obviously that didn't dismiss the thing, because this is a very basic example of how that might work. But ultimately, as a consumer of this library, you wouldn't have to know like any of the implementation details as long as it did what you wanted. You just install the package and then integrate the navigator into your application. So at this point, I think the question, maybe people are like, okay, fine, like enough of that, but like what do I use? I think I've hopefully described some of the trade-offs, some of the issues that you might encounter when using either of these approaches. I think it's important also to not like judge either of them by the current situation that they're in terms of like what potential they have. Of course, for your current project or your next project, definitely judge them by the situation that they're in. But I think there's a lot of opportunity in both areas to get a lot better. And ultimately, I think it's really good that we have these two options available. Some people don't want to write any native code. Some people have iOS and Android developers on their teams ready to help them out. Some people just love the platforms that they work with so much that they can't even fathom using an API that isn't native on it. And so these are kind of things you just have to consider depending on your company situation, your own situation, and the product need that you have. Yeah, so that's about it. I guess the last thing I just encourage people to maybe not be so tribal about the technology that you use. There's a lot of people out there who seem to enjoy like picking a side in this, like which approach they agree with the most, and then thinking that anyone that doesn't do that approach is just an idiot and they don't know what they're doing. And I think it's kind of silly to do that. I think everyone benefits from having different approaches. And if it doesn't work for you, hopefully try and see what it does that your approach doesn't do so well, and maybe try and learn from that, or maybe use it when it's useful for you. That's it. Thank you. Sure.
So, one quick question, maybe? Okay. Oh, thank you. Thank you, Brent.
Cool. All right, just come find me later if you have questions.